Hello, today we are going to look at how to set up simulation mechanism for windshield wiper using Ansys rigid body dynamics module. First, get the assembly of windshield wiper mechanism geometry into workbench, then connect the rigid body dynamics system to the geometry tab of the geometry system. The assembly of the windshield wiper mechanism look like this. It consists of various components like screen, arm, blade, both on the left and right side. The first task to set up the simulation of mechanism is to define the joints. Under connection, if Ansys has automatically detected any contact while importing the geometry, please do delete them. Now let's start defining the joints. Before I start defining the joints, just for easy definition of the joints, we can hide the screen geometry from the display. So let's start with the motor crank. The first one is a revolute joint between the crank and motor. This revolute joint is grounded, so it's body to ground revolute joint. Having defined this, then we have to define different joints between the connecting members. In order to make the joint definition easy, the wiper arm and the blade is hidden from the display. Now we can use the explode view option to make the joint definition easy. The next task is to define the revolute joint between the crank offset rod and the crank pin. To define this, first select the reference and the mobile body. Now it's a body to body revolute joint. Next task is to define one more revolute joint between the pin and the connecting surface. So one more revolute joint here. The next task is to define one more revolute joint between the plates. Now between the pin and this body, then pin and this body. This joint is going to be a fixed joint, and there is another joint between this and this body. This is a revolute joint. We defined these. Let's make sure things are okay. Next, define a revolute joint between the pin and grounding tube. Next task is to define one more fixed joint between the right arm here and the connecting pin. So it's this and this. Highlight the joints, define a revolute joint. Now we have set up all the necessary joints on one side of the wiper mechanism. Now we have to set up the joints on other side of the wiper mechanism. Similarly, use the explode feature. First, define the revolute joint between these two bodies. Use F7 to bring it to a fit view. Next revolute joint is between these two bodies. Then between this and this, it's a fixed body to body joint. and between these and the bearing it's a revolute joint. Now it's time to bring in the left arm to define a fixed joint between these two bodies. Fixed joint. I'll fix this and make sure all the joints are defined for this mechanism. All the joints are defined for this mechanism. Next task is to ground this particular body. This is fixed joint, and also it's time to bring up the blades that attach to the arms. Can define a fixed joint between the wiper arm and the blade as such. And one more joint definition between I think all the joints are defined. Let's make sure it's going to use the configure option just to see whether it works as expected. Yeah, it looks working, but whatever reason this place, the other blade, the other side of the blade is not moving along with that. It looks there is some problem with the definition of joint between this sweep rod and this pin. Let's go and investigate that. Let's see where that joint is. This is the joint. This is between this and this, and we can see that for this joint we have chosen this as the reference, but for mobile body by mistake we have chosen this body. Now let's explode this and let's redefine that. This is basically not from this body, this is supposed to come from this body. This is not two phases, it's only one phase, that's this. Having defined that, let's fit it to the screen. And joints, let's try to configure again and make sure it works excellent. So this works as expected. Alright, now it's time to show all bodies including the windscreen. So windscreen cannot be floating in the space, so let's fix this to ground. And also please note that this windscreen is curved. In real scenario, the blades are expected to sit on the curved windscreen, but this being the rigid body analysis, it's really not taken care of. The curvature and the blade flexibility is not really taken care of. The glass is present in this model just for a visualization purpose and a reference purpose. Having done this, the next step is to apply some kind of joint condition. So what I'm going to do, I'm going to apply just drag and drop this revolute joint and say we are going to enforce rotational let's say a rotational velocity. Let's say it's rotating at a constant velocity of 30 rpm, revolution per minute. So what it means is that in 1 minute it's going to complete 360 degrees. sorry, it's 30 rpm. It's going to complete 30 revolution per minute. Let's see how much degrees it can cover within revolution per second. This is revolution per second. So 0.5 revolution per second. What it means is it takes 2 seconds to complete one full 360 degree. So let's simulate this for 4 seconds, such that we expect this to complete 2 cycles of revolution. So this one is really not required. Let's delete this row. So it's at constant velocity of 30 rpm per second. Let's insert deformation probe. It's total deformation. Before we solve, save the project. We are ready to solve now. It's going to take few seconds to solve this problem for 2 sweeps of wiper movement. So let's do some housekeeping activity by that time. Yeah, the result is almost ready. Let's look at this animation. Something seems wrong here. This is not behaving as expected. Let's go and investigate what really went wrong. Stop this animation. Let's come here. This end is properly fixed. Let's look at this joint. Yeah, this joint. Yeah, this is supposed to be a fixed joint, not a revolute joint. Change this to fixed joint and save the project. Solve it again and let's see how it goes. Yeah, the solve is done. Let's look at the animation. It looks okay this time. Let's play the animation. Okay, it's quite fast. What we could do is we could increase the number of frames to 40 frames and reduce the time lag between consecutive frames. Let's play it again. All right. So find this exercise is quite useful to you. Thank you for listening. Next exercise I will post keeping any one of these body as flexible and try to understand the stresses produced in any one of these links. Thank you for watching.